we can start the p block elements. P block elements. Good. P block elements. P block elements. Chapter name. Hello. P block elements. Okay. So what do you mean by P block elements? Okay. Example boron. Okay, boron. Is atomic number of boron? Atomic number 5. Okay. Z is equal to 5. So what will be the electronic configuration is 1s2, 2s2, 2p1. And next one boron carbon. Atomic number will be 6. So what is electronic configuration will be 1s2, 2s2, 2p2. When this last electron comes into a p orbital, thus elements are called p block elements. So what do you mean by p block elements? The elements which last electron enters into a p orbital. So what do you mean by s block? The elements which last electron enters into a s orbital. What do you mean by d block elements? Elements which last electron enters into a d orbital. So good. Right. The elements which last electron enters into a p orbital. Okay, so what are the groups p block elements? They include group 13th to 18th in a periodic table. Okay, group 13th to 18th in a periodic table. What is the general electronic configuration is ns2 np 1 to 6. Okay. ns2 np 1 to 6. So what are the groups? The groups boron family, carbon family, nitrogen family, oxygen family, halogens and inert gas. So what is the electronic configuration will be ns2 np1, ns2 np2, ns2 np3, ns2 np4, ns2 np5, ns2 np6. Okay, kodukadungo. Okay, ns2 np1, ns2 np2. So what is their valence electron will be? What is the total number of valence electron of boron family? 1. Again 1. Again. What is 3? What do you mean by valence electron? Number of electrons present in valence shell. What do you mean by shell? In nth shell, in s and p subshell contains how much electrons? 3. So what is the number of valence electron in boron family? 3. Carbon family 4. Nitrogen family 5, 6, 7 and 8. What are their oxidation state will be? Okay, boron family ns2 np1 ground state. So what is the tendency for removal of 1 electron, for addition of 1 electron? What will be the tendency? Removal of 1 electron. Plus 1 or minus 1? Plus 1. So what is the oxidation state in ground state is plus 1. In excited state, this electron is excited. So what is the total number of unpaired electron? 3. So what is the oxidation state will be? Plus 3. Okay. So what are the common oxidation state of boron family will be? plus 3 and plus 1. NS2NP2 for carbon family. So what is oxidation state in ground state? What is in oxidation? Plus 4. So what are the common oxidation state? Plus 4 and plus 2. Nitrogen family, NS2NP3. What is oxidation state? Plus 3 and minus 3. You can accept 3 electron or remove 3 electron. In excited state, what is the oxidation state? What is the total number of electron? 1, 2, 3, 4, 5. S, P, D. Okay. So what is oxidation state is plus 5. Okay, 1, 2, 3, 4, 5. So what is the total number of unpaired electrons? 5. So what is the common oxidation state? R plus 5 plus 3 and minus 3. NS2NP4. NS2NP4. So what is oxidation state will be? Plus 2 and minus 2. Excited state plus 4. Excited state plus 6. So what are the common oxidation state? Plus 6, plus 4, plus 2 and minus 2. Next, NS2NP5. What is oxidation state will be? Plus 1 and minus 1. Next, plus 3. Next, plus 5. Next, plus 7. So what are the common oxidation state will be? Plus 7, plus 5, plus 3, plus 1, minus 1. Next, NS2NP6. So what is oxidation state in normal അല്ലെങ്കിൽ ground state? 0. They do not have the tendency to participate in reactions, so they are called inert gases. First excited state plus 2. Next, plus 4. Next, 6. Next, plus 8. So what are the common oxidation state? Plus 8, plus 6, plus 4, plus 2. So these are the common oxidation state of P block elements. So all these higher oxidation state. So what is higher oxidation state here? Plus 3. Here, plus 4. Here, all these are equal to what? Valence. So these oxidation states are called what? Group oxidation state. This oxidation state, group oxidation state. So what do you mean by group oxidation state? The higher oxidation state and they equal to, they are called group oxidation state. So what do you mean by plus 3 oxidation state? So how much valence electron, how much electron they are present in valence shell? 3. So giving all these 3 electrons, giving all 4 electron, giving all 5 electron, giving all 6 electron. So what do you mean by plus 1, plus 2, plus 3, plus 4, plus 5 and plus 6? What is common in oxidation state? Giving 1 electron, that means they are not giving 2 electron. Giving 2 electron, not giving 2 electron, not giving 2 electron, not giving 2 electron, not giving 2 electron. This oxidation state is due to inert pair effect. This oxidation state is due to inert pair effect. So what do you mean by inert pair effect? What do you mean by inert pair effect? So what do you mean by inert? That is reluctance, not interested. Reluctance means not interested. Reluctance to what? To take part in reaction. What do you mean by inert gases? The gases which do not have a tendency to take part in a reaction. So what do you mean by inert? Means that is not interested to take part in a reaction. In this oxidation state, that is plus 1 and +3. So how much electron shows not interested to take part in reaction? 2 of electrons, a pair of electrons. Okay, so this effect is called inert pair effect. So what do you mean by inert pair effect? It is the reluctance of pair of electrons to take part in reaction. So what are these pair of electrons? This pair of electrons are present in which orbital? S orbital. We have 2 electrons in S orbital and 1 electron in a P orbital. All these 3 electrons are take part in reaction. They should show what oxidation state? +3. If these 2 electrons do not have the tendency to take part in reaction, if the 1 electron is take part in reaction, they shows what oxidation state? +1. Here also what they shows? +2. Here shows +3, etc. Okay, so which orbital shows reluctance to take part in reaction? The electrons present in which orbital? Outermost S orbital. Okay, so what do you mean by inert pair effect? It is the reluctance of electron present in outermost S orbital to take part in reaction. So what is the oxidation state due to inert pair effect will be equal to group oxidation state -2. Okay, group oxidation state -2. Okay, so what happens in inert pair effect down the group? Down the group this effect is increases. Down the group this effect is increases. That means S orbital are more closely packed to the nucleus. It's simply like boron, aluminium, gallium, indium and thallium, boron family. Okay, so what is the electronic configuration will be? 2s2 p1. What is the electronic configuration will be? 6s2 6p1. Okay, S orbital. Okay, orbitals are like boys. Okay, nucleus, mum, nucleus. S orbital, girls. They are always have a particular relationship with they can't go anywhere. P orbital, they can go anywhere and they can comes to nucleus or mum. Okay, there is a DJ program at 12 o'clock. Okay, DJ program at 12 o'clock. Okay, night Saturday program before marriage, Saturday DJ program. Okay, we have 2 girls, 2 electrons in S orbital and 1 electron in P orbital. Okay, this mom has a tendency to take part in the DJ. How much electron? Only 1 electron. Okay, so here 2s2 2p1, small 2 girls and a small 1 boy. Okay, this mom have 2 large girls, 1 large boy. Okay, so boron mom basically 3 kids. Okay, DJ program no problem. This mom allowed to these 3 students അല്ലെങ്കിൽ 3 children to go for DJ. Small boys or girls no problem for child. Small students, small കുട്ടികൾ. Okay, but thallium large girls 12 o'clock DJ not interested because the stability. Not interested. So thallium have a larger tendency for which effect? Inert pair effect. So down the group inert pair effect is increase. That means we have 2 girls for boron mum and thallium mum. Boron 2 girls are smaller and they are take part in DJ. Okay, but thallium have 2 larger girls not interested to take part in a reaction. This effect of inert pair effect. Okay, so down the group inert pair effect is increases. So which is more stable in boron or decrease plus? So which is more stable and why? BCl3 or TlCl3? BCl3. Due to boron is more stable in +3 than thallium. Which is more stable? TlCl. Due to thallium is more stable in +1 than boron. Next, AlCl3 or GaCl3. Which is more stable and why? AlCl3. Due to in +3 oxidation state, aluminium is more stable than gallium. GaCl or InCl? InCl. In +1 oxidation state, In is more stable than. So all depends the stability of oxidation state. All chemical reactions are depends their oxidation state. If boron is reacting with oxygen, so corresponding oxide will be formed. So what is the charge of oxygen? -3. So what is the stable oxidation state of boron? +3. Oxygen -2. പറഞ്ഞൂടെ എന്ത് ചിങ്ങന്മാരാണോ അല്ലേ? +3. So what will be the compound formed? Will be B2O3. Okay. Thallium is reacting with the Cl. What will be the product? TlCl. Okay. Phosphorus is reacting with the chlorine. What is the product formed? Will be PCl5, which is the oxidation state +5. Okay. So nitrogen mostly like what? -3. Most electronegative atom. Oxygen mostly like what? -2. Most electronegative atom. Fluorine only shows a most electronegative atoms. All these chemical reactions are depends their oxidations. Okay. ഇത് വീക്കുത്തി ഇലക്ട്രോൺ ഒന്നും കൊടുക്കരുത്. ദിസ് ഇസ് വാലൻസ് ഇലക്ട്രോൺ. ഓക്കെ. V.E ഒന്നും കൊടുക്കരുത്. ദിസ് ഇസ് വാലൻസ് ഇലക്ട്രോൺ. அந்த மாதிரி கொடுக்காதுங்க. வேலன்ஸ் எலக்ட்ரானே கொடுங்க. If you have any doubt, you can ask me. Okay. Don't ask like that when we are mixing Coca-Cola and Pepsi. What will happen? Okay. உங்களுக்கு S block elements முடிஞ்சதா? Classification of elements பார்க்கட்டும். You should have an idea about how these all oxidations comes. Okay, based on their electronic configuration. Okay. ഇതിൽ മലയാളീസ് ആരെങ്കിലും ഉണ്ടോ? മലയാളീസ് ആരുമില്ല? എവിടുന്ന്? നാട്ടിലാണ് പഠിച്ചത്. ഈ ബേസിക്കലി തമിഴ്നാടാണ്, പക്ഷെ പഠിച്ചത് കേരളത്തിലാണ്. നീ ശരിക്കും മലയാളിയാണോ തമിഴ്നാടിയാണോ? മലയാളം. അതെവിടെയാണ് നാട്ടിൽ? കൊല്ലത്തോ? ഞാൻ കൊല്ലത്തെ പഠിച്ചത്. TKM. കൊല്ലം TKM അറിയാത്ത കൊല്ലംകാരിയോ? ഇറങ്ങി പോടുന്നു. നെക്സ്റ്റ്. പാലക്കാട്. കൊല്ലത്തെ ആകെ ഏറ്റവും ഫേമസ് ആയിട്ടുള്ള സാധനം TKM കോളേജ് അല്ലേ? ഈ കൊല്ലത്ത് എവിടെയാണ്? കരുനാഗപ്പള്ളി. കരുനാഗപ്പള്ളി കുറച്ചും ഇങ്ങോട്ട് വന്നല്ലേ? കുറച്ചും ഇങ്ങോട്ട് വന്നു. കരുനാഗളം, കായപ്പള്ളി. ഞാൻ അറിഞ്ഞു വെച്ചോ, കൊല്ലത്തെ ഏറ്റവും സംഭവമായിട്ടുള്ള സാധനം TKM കോളേജാണ്. CET കോളേജ് കേട്ടിട്ടുണ്ട്, ട്രിവാൻഡ്രം. CET ട്രിവാൻഡ്രം. ഈ എന്ത് കൊല്ലം കാര്യമായിട്ട് ഒരു സാധനം അറിയില്ലൊക്കെ. இது மட்டும் போதும். இனேட் பெர்ஃபெக்ட் நான் சொல்லுவேன். இது மட்டும் போதும். ஆஸ்க் +2 ஆக்சிடேஷன் காட்டுது. +3 ல காட்டுது. +3 காட்டுது சார். காமா காட்டிப்போ. These are the common oxidation state and p block elements can shows variable number of oxidation state also. Okay, these are the common oxidation state. They should shows based on their electronic configuration, but they can shows other oxidation state also. Carbon can shows -2, -1 like in carbides, and they can shows +3 also. They show zero oxidation state in organic compounds. Okay, every compounds. So these are their common oxidation state based on their electronic configuration. We can predict. So they can shows other oxidation state also. Now next.
Gallium boron and gallium. அது வந்து GnCl3 கூட ஆட் பண்ணும்போது GnCl3 ஃபார்ம் ஆகுமா இல்ல
GnCl3. Gallium is like +3 more than +1.
+3 more. அது எல்லா சென்டர்
Thallium the basically +1 more stable. Others all are stable in +3. And indium also +3 is stable. Thallium is the only one basically stable in +1 due to higher inert pair effect. Others all are stable in their +3. We will discuss it all in oxidation state. Okay, just generally soldier. Okay, next inert pair effect. Heading up inert pair effect. Inert pair effect. It is the reluctance of pair of electrons present in outermost s orbital to take part in reaction. Okay, point down the group inert pair effect is increases. Down the group inert pair effect is increases. Okay, next one, reason for anomalous behavior. Of first element. Reason for anomalous behavior of first element. Okay, so what are the basic reason for the anomalous behavior of first element in every group? Already you discussed in classification of elements and already you studied in S block elements. What are the anomalous reason, anomalous properties of lithium? What are the anomalous properties of beryllium? So what are the reason for this anomalous behavior of first elements in every group? Okay, correct. Smaller size. Next, high ionization energy. Third, high electronegativity, and fourth one is absence of vacant d orbital. Okay, in s block elements it will be the fourth property will be high polarizing power, which will be the fourth property will be high polarizing power more than what absence of vacant d orbital. But in p block element, which will be the fourth property, absence of vacant d orbital. So what are the reasons? Smaller in size, high ionization energy, high electronegativity, and absence of vacant d orbital. Okay, good. Reason for anomalous behavior of first elements. Reason for anomalous behavior of first element: smaller in size, high ionization energy, high electronegativity, absence of vacant d orbital. Okay, so what are the anomalous properties? So what are the basic anomalous properties? Okay, so what are the general properties shown by boron, aluminum, boron family and carbon family? So what are the anomalous properties of boron and carbon? So all these elements generally shows what they can form strong p-pi bond. They can shows what strong p-pi bond. They cannot shows what d-pi p-pi or d-pi due to the absence of d orbital. So they can shows what strong p-pi bond. In case of overlapping of pi orbitals, that is p-pi. Okay, p-pi. It is 2p orbital and it is 2p orbital and it is 3p orbital. 4p orbital. It shows a larger extent of overlapping, 2p or 4p. 2p. So which is the strongest p-pi അല്ലെങ്കിൽ pi bond will be 2p. So first elements have which orbital? 2p orbital. So they can shows what strong p-pi bond and their maximum covalency is 4. So what is their maximum covalency is 4. That means how much covalent bond they can form? 4, due to they have a 2s and 2p, do not have what d orbital. So s orbital, 1 orbital, how many? 3 orbitals, 3 covalent bond, 4 covalent bond. So what is the maximum covalency of first elements? 4. So maximum covalency is 4. It is applicable for boron, carbon, nitrogen, oxygen, fluorine, etc. Okay, so there is a question that Al can form AlF6 3-, but boron cannot. Why? Okay, so what is the oxidation state of aluminum and boron? +3. What is +3? So this is stable oxidation state and a possible oxidation state for boron. So why BF6 3- is not formed? Boron cannot extend their covalency beyond 4. Boron cannot form 6 bond with the fluorine. Maximum covalent bond possibility is 4. Okay, so here it is not possible, it is possible. Aluminium is 3s2, 3p1 and 3d0. So it has a vacant d orbital, so it can extend their covalency beyond 4. So boron have a maximum covalency of 4. Okay, 2 properties. They can form strong p-pi bond. They can form strong p-pi bond. Maximum covalency is 4. Maximum covalency is 4. Okay. Just to give a question. Aluminium can give AlF6 3 minus, but boron do not gives BF6 3 minus. Why? Aluminium can give AlF6 3 minus, but boron cannot give BF6 3 minus. Why? Okay, so what is the answer? Aluminium can extend their covalency beyond 4 due to the presence of a vacant d orbital, but boron cannot extend their covalency beyond 4 due to the absence of a vacant d orbital. So there is a presence of vacant d orbital and there is an absence of vacant d orbital. Okay. Settle. Up next. Okay. Okay. Boron family. Boron family group 13. Good. In plus 1 B block we have a boron family and carbon family. Boron family group 13. Okay, so what are the elements? Boron, aluminium, gallium, indium, thallium. Babu and Ali. Gada, India, Talle, Dishum. Babu and Ali, Gadaye, India, Talli. Babu, Ali, Gada, India, Talle. Good. Tamil akanikku ariyilla. Alle. Tallin endha Tamil paraya? Adikkirathu. Talle. Malayalathilu Talle. Good. Gadaye, India, Talli. Talli. Not push. അത് തള്ളു. അത് ഇങ്ങ തള്ളു പുഷ്. അങ്ങ തള്ളു. ബാബു അലി ഗാഥ ഇന്ത്യ തള്ളു. Boron, aluminium, gallium, indium, thallium. Okay. So what are the occurrence? Occurrence first one is boron. Okay. Boron is a rare abundant element in earth crust. Okay. So where these elements all are extracted? Earth crust. Okay. So boron is a very rare abundant element in earth crust. What is the first most abundant element in earth crust? First most. Ara. Next. Come on. Game starts now. Come on. Ara. Oxygen. First most abundant element in earth crust is oxygen. Due to most of the metals are exist in their oxides, aluminium, lead, all are exist as their corresponding oxides. Okay, second one. Silicon. Third one. Aluminum. Okay, so here boron have, this is the oxygen abundance is 46.6% abundance by mass of earth crust. That means 100 gram of sample taken, 46.6 gram will be what? Oxygen. Okay, here the abundance of boron is 0.001%. So boron is a very rare abundant element in earth crust. Okay, first of all, boron is a rare abundant element. Boron is a rare abundant element in earth crust. Boron is a rare abundant element in earth crust. Okay, bracket 0.001 by percentage by mass. By mass. Okay, so what are the stable isotopes of boron? B10 and B11. Okay, the stable isotopes are B10 and B11. Stable isotopes are B10 and B11. Okay, boron is a black solid. Boron is a black solid. Boron is a black solid. Okay, boron is exist as. Boron is exist as so what are the important compounds of boron? Borax, kernite, colemanite or okay, L silent, colemanite, in India colemanite. So boron is exist as borax, kernite, colemanite. And what is orthoboric acid? Orthoboric acid, it is simply H3BO3. Colemanite, kernite, borax, orthoboric acid. So these are the important compounds of boron. Okay, next one, aluminium. Okay, so what is the first most abundant element in earth crust? Oxygen. Second one is silicon. Third one is aluminium. Oxygen is a metal or non-metal? Non-metal. Silicon is a metal or non-metal? Non-metal. Aluminium is a metal or non-metal? So aluminium is the third most abundant element and first most abundant metal in earth crust. Okay, it is the third most abundant element. Third most abundant element and first most abundant metal. First most abundant metal in earth crust. First most abundant metal in earth crust. Okay, L is exist as aluminium exists as L2O3.2H2. So what is the important compound of aluminium is bauxite. Okay, next one is Na3Al(F6) is called cryolite. Cryolite. So these are the important compounds of aluminium, bauxite and cryolite. Okay. தெரியல, வாய் திறந்து ஏதாவது பேசுங்களேன். Okay, next one is electronic configuration. Electronic configuration. Electronic configuration. Electronic configuration. Code. Electronic configuration. So what is the general electronic configuration is? What is the general electronic configuration? NS2 NP1. Okay, so here we have boron, aluminum, gallium, indium and thallium. Okay, so periodic table. Okay, periodic table. First period contains which are the hydrogen and helium. Second period, third period. Second period, third period. Fourth period, fifth period, sixth period and seventh period. So these are 1s1 and 1s2. Okay, this is 2s and 2p. This is 3s and 3p. This is 4s and 4p. Between 4s and 4p there is a 3d orbital. 5s and 5p. There we have a 4d orbital. 6s and 6p. Here we have 5d and 4f orbitals. Okay, here it is 7s and 7b. Here we have a 6d orbital and 5f orbital. Okay, so what are the gases we and random? So what are the okay, so what is the electronic configuration of boron will be helium 2s2 2p1. Next one aluminum, neon 3s2 3p1. Next one gallium, argon 4s2 3d10 4p1. Okay, so what is electronic configuration of boron will be helium, neon, argon, krypton, xenon. Okay, 2s2 2p1, 3s2 3p1, 4s2 3d10 4p1, 5s2 4d10 5p1, 6s2 440 5d10 and 6p1. So what are the atomic numbers will be? So what are the atomic numbers here? 10 18 36 54 and 86. So what is the atomic number of our first group? Plus 1. Okay, plus 1 11 19 37 55 and 87. So what are the second group will be? 12 20 38 56 88. So what number of halogens will be? Minus 1. 9 17 35 53 and 85. What is oxygen family will be? Halogen oxygen family will be minus 2. Nitrogen family minus 3. Carbon family minus 4. Boron family minus 5. So 10 minus 5 5. Next 13. Next 31. Next 49. Next 81. Okay, similar the atomic numbers. Okay, based on atomic number of inert gases. Okay, good. There will be simple questions like which are the elements corresponding in a same group, giving the atomic number 18 36 54 31 48 and 81 etc. Okay, simple type of questions. Second chance ആരെങ്കിലും ഉണ്ടോ? Second chance. Repeater. എല്ലാവരും ഫ്രഷ് റിപ്പീറ്റേഴ്സ്. എല്ലാവരും റിപ്പീറ്റേഴ്സ് അല്ലേ? റിപ്പീറ്റർ ഉണ്ടോ? No one. No problem. Great decision. No problem. ഒരു പ്രശ്നമില്ല. ബോർഡ് പത്ത് എഴുതാതെ സിമ്പിളാണ്, നിങ്ങളെ എഴുതണം. 2:2 P1, 3:3 P1, 4:3 D10, 4 P1, 5:4 D10, 5 P1, 6:4 D10, 5 D10, 6 P1. അല്ലേ? സെറ്റല്ലേ? ഓക്കെ ഇനി മക്കളെ കൊടുത്ത പ്രോപ്പർട്ടീസ്, അറ്റോമിക് റേഡിയസ് അങ്ങനെ കൊടുത്ത അറ്റോമിക് ആൻഡ് ഫിസിക്കൽ പ്രോപ്പർട്ടീസ്. അറ്റോമിക് ആൻഡ് ഫിസിക്കൽ പ്രോപ്പർട്ടീസ്. Atomic and physical properties. Atomic and physical properties. Atomic and physical properties. Okay, first one is atomic radius. Atomic radius. And atomic radius is generally down the group and the increase. Generally down the group increase. But here, boron, aluminium, gallium, indium and thallium. Down the group increase means thallium, indium, aluminium. So there is an exception between aluminium and gallium, which have larger size. Aluminium is greater than gallium due to the so what is electronic configuration of gallium is 4s2 3d10 4p1. So d orbitals, so they have a poor shielding or higher shielding. D orbital poor shielding. So what happens to the effective nuclear charge? Increases. So what happens? The size decrease. So there is a presence of what are the d orbitals. D orbitals. So what happens? The size is decrease. Okay. So due to the poor shielding of d orbitals of gallium, d orbitals of gallium. So atomic radius generally down the group increases, but here aluminium have larger size than gallium due to the poor shielding of d orbitals of gallium. D orbital poor shielding, effective nuclear charge increases, radius decreases. Effective nuclear charge ZEFF. Okay അല്ലേ? Next one is ionization energy. Ionization energy. Ionization energy. Ionization energy. Okay. So generally down the group what happens? Generally down the group decreases. Okay, but generally down the group decreases means generally down the group decreases. So boron greater than, aluminum greater than, gallium greater than, indium greater than, thallium. So why this ionization energy is decreases down the group? With the increasing size. So there is an exception in size. So there should be an exception in ionization energy, which have larger, gallium have a larger than. And the same way here have an exception between indium and thallium also. Due to thallium have which orbital? D and F orbital. So there will be more poor shielding. So they do not shows a change in water atomic size, but they shows a change in water ionization energy. Okay, so here generally down the group decreases, but gallium greater than aluminum due to the poor shielding of d orbitals of gallium. Okay, and TL greater than iron due to the poor shielding of d and of orbitals of thallium. Okay, gallium have a poor shielding of what? Thallium have a poor shielding of doubt. If there is a poor shielding of d and f orbital, there should have a change in size. Okay, so basically these elements do not have any idea about periodic table and electronic configuration. We are generalizing the properties of elements based on periodic table. It is not 100% clear. Okay, so these elements shows their nature. Okay, so we are giving explanations based on what we have. Okay, so there is a change in size. We are giving explanation that it may be because of poor shielding of d orbitals. There is a change in ionization energy, so we are giving another explanation. It may be because of poor shielding of d and f orbital. We don't have any other more explanation for it. Okay, simple. So all these are fake. Inorganic chemistry, completely fake. ഇതിന് ഈ കുട്ടികൾ ക്യാമറ നോക്കി കാണും. ഇപ്പോൾ ഈ ക്ലാസ്സിൽ ക്യാമറ നോക്കിയിട്ട് ഓഫ്ലൈൻ പിള്ളേർ വേറെ ഉണ്ടോ? ഓഫ്ലൈൻ സ്റ്റുഡൻസ് വില്ല് വാച്ച് ദിസ് വീഡിയോ അഗെയിൻ. Okay, ionization energy. Next one is electronegativity. Electronegativity. Generally down the group എന്താ മക്കളെ? Generally down the group electronegativity generally down the group decreases. But here here what happens? Inge par okay, but here boron to aluminum decreases. Boron to aluminum decreases, then it marker. Okay, boron to aluminum decreases, then it okay, so what is the behavior of electron negativity in boron family? Decreases up to Aluminum. Then it increases. Here that is after boron, so which is the highest electronegative element is thallium. From this increases means boron and aluminum, which have larger aluminum. Here boron, next increase gallium greater than, indium greater than, and thallium. So which is the least electronegative element is aluminum. So which is the most electropositive element in boron family? Aluminum. So it is the least electronegative, most positive element in aluminum. So which of the compound, which of the element shows more ionic compound in boron family? Aluminum. Boron cannot give the ionic compound, but which can give the, due to it is more electropositive. Okay, good. Generally down the group decrease, but here decrease up to aluminum, decrease up to generally down the group decrease, but here decrease up to aluminum, then increases, okay, that is electronegativity. About that point, aluminum is the least electronegative and most electropositive element. Aluminum is the Al is the least electronegative and most electropositive element. Okay. Set metallic character. Metallic character. Metallic character. Okay, generally down the group metallic character, what happens? Increases. Metallic character down the group increase along the period. Non-metals, inert gas, alkali metals, up along the period metallic character decrease, and down the group it increases. So here boron is a non-metal and others are metal. So this is the third anomalous behavior. What are the first and second? They can form strong p-pi bond. Is boron is a non-metal and others are metals. So after completing the boron family, we have to find out what are the anomalous behavior of boron. We have addition with these 2 points. Okay, boron is non-metal and others are metals. Okay, boron is a non-metal and others are metals. Next one is melting point. Melting point. Melting point. Melting point. Okay, so first we have to remember boron, aluminum, gallium, indium, and thallium. Which have least melting point? Gallium. Gallium have the lowest melting. It is lowest melting point. So what happens? Boron to gallium decreases or increases? Decreases. So boron decrease. Okay, from gallium. Okay, which will have a lowest melting point is gallium. Which have highest melting point is boron. Okay, good. Boron to gallium decreases, boron to gallium decreases, then increases. Boron to gallium decrease. then in highest gallium illa boron to gallium decrease, it is then there is a smaller increase which have a non-metal nature. Boron, there will be strong bonds, covalent bonds. Okay, boron it is smaller size strongest bonds. And melting point do not depends all these periodic properties. Melting point only depends what their crystal structure. Okay, only depends their crystal structure. It is variable for each element. Okay, so based on periodic properties we cannot find out the general behavior of a melting point. Okay. So boron to gallium decreases, then increases. Okay, so which have a lowest melting point? Gallium have a lowest melting point and boron have a highest melting point. Boron have a lowest melting, gallium have a lowest melting point and gallium have a highest melting point. Okay. Gallium have a lowest melting point. So there is a question. Okay, which of the element in boron family will be exist as a liquid at room temperature? So which have a lowest melting point here? Gallium. So is there only a possibility for gallium to become the liquid at room temperature? Okay, so it have a lowest melting point, but high boiling point, not more than what? Boron. Okay, but it have in the high boiling point as comparing with his melting point. So it is used to measure what? High temperature. High temperature, it is used to measure high temperature in thermometer or high temperature thermometer. Okay, the temperature the thermometer we are used to measure high temperature are called high temperature thermometer. Okay, so there we are using due to it have a higher boiling point. So even it has a low melting point, it is used to measure high temperature in high thermometer due to it high boiling point. Okay, so another question, which of the element in boron family is used to measure high temperature? Gallium. Okay, gallium have a high boiling point. Gallium have a high boiling point. So it is used to measure. So it is used to measure high temperature in. So it is used to measure high temperature in high temperature thermometer. High temperature thermometer. High temperature thermometer. Even it has a low melting point. Even it has a low melting point. Even it has a low melting point. So gallium have a low melting point, but it has a high boiling point. So it is used to measure high temperature in high temperature thermometer. Okay, next one is density. 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 Okay, density down the group and along the period. So what do you mean by density is equal to mass by volume? Along the period, what happens to the atomic mass? Increases or decreases? Increases. What happens to the size or atomic volume? Decreases. So what happens? Increases. So along the period, density is increases with increasing atomic mass and atomic size. Down the group, density is equal to mass by volume. Down the group, what happens to atomic size or volume? Increases. Increases. What happens to atomic mass? It also increases, but larger than this increase. What will be the atomic mass difference between carbon and nitrogen? It's only 2. So there is a large So down the group there is a large increase in what atomic mass than what atomic size. So density down the group also increase. So which of the periodic property is increases along the period and down the group density? Okay, what is the density? Okay, pointed down the group density is increases. Down the group density is increases. Down the group density is increases due to larger increase in atomic mass than atomic size. Okay, so what are p block elements, what are the different groups, what are the general electronic configuration, and what are the general oxidation state, what do you mean by inert pair effect, and what happens down the group, and what are the reason for the anomalous behavior of first elements in every group, and what are the general anomalous properties of first elements, and what are boron family and their occurrence, electronic configuration and anatomic properties like atomic radius, ionization energy, electronegativity, density, metallic character, and melting point. Read. bookkeeper. There. Okay. Alright. What is the atomic radius of boron family? அது எடிட்டு நிற்கடா ஸ்டாண்டு. ஓகே, வாட் இஸ் அட்டாமிக் ரேடியஸ் ஆஃப் போரான் ஃபேமிலி? குரூப் boron family. Generally boron family. I am not asking the general trend of atomic radius down the group, just asking the atomic radius trend of boron family. What happens? Is there any exception is happening, and due to why?
Between aluminum and gallium.
Aluminum and gallium, which is more which have a higher radius?
Aluminum.
Aluminum. Due to why? Next one. Which have a higher ionization, thallium or indium? Thallium. Why?
So due to D and F. Pore shielding.
Pore shielding of D and F orbit. Good. What is the trend of melting point of boron family? Thallium, mangaduli.
Gallium is the least
Melting point. So what happens? What is the trend down the group?
Down the group increases.
Down the group increases. Correct. Enga increases. Yar increases.
Boron to gallium decreases.
Boron to gallium decreases. Then
gallium
increases. So which have highest melting point? Boron. Do you mean by inert pair effect? அது என்னடா ஸ்டாண்ட் அண்ட் சே ரிலக்டன்ஸ் சொல்லு.
Pair of electrons in the outermost s orbital to take part in the reaction.
So what happens inert pair effect down the group? Decreases. Yeah. Increases. Sit down. What are the common oxidation states of boron family? So what happens to stability of +3 down the group? Decreases. What is the trend of ionization energy of boron family? Gallium higher than aluminum. Then same. In the same way. I don't say it. Okay. Par.
Stronger than 3p, 4p.
Smaller orbitals. So there will be extent of overlapping is more than higher pp orbitals. So you have to learn the extent of overlapping is higher for 2p, 2p or 4p, 4p. 2p, 2p have a higher extent of overlapping. So
Down the group inert pair effect increases.
Okay.
Chemistry definition.
Definition due to s orbitals are more closely packed to the nucleus. S orbitals are more closely packed to the nucleus. So you will not understand what they means, because if I am saying that s orbitals are more closely packed to nucleus, 2s orbital or 6s orbitals are more closely packed to s orbitals, so there will be a doubt. So that's why I changed the chemistry definition. Okay. Okay. What is the general trend of ionization energy of boron family?
gallium and aluminum. Gallium increases.
Gallium greater than aluminum. Then
Thallium is greater than
indium.
Stability.
Why?
Due to the stability of the in gallium and aluminum, it is due to the stability of the orbitals. In indium and thallium, it is due to the stability of the atom.
என்ன சொல்ற? Stability of மாங்காத்தொலி போட வந்துட்டு. சொல்லு. What is the trend of electronegativity of boron family? Trend of electronegativity of boron family down the group. Boron to aluminum decrease. Then aluminum to thallium. Thallium to aluminum. இது என்ன ட்ரெண்டா? boron to aluminum decrease. பின்ன thallium to aluminum. Down the group சொல்லுடா. இது നീ നീറ്റാ എഞ്ചിനീയറാ കൂടാ പൈത്യക്കാരാ അല്ലേ? സിറ്റ് ഡൗൺ. ബോറോൺ ടു അലുമിനിയം ഡിക്രീസ്, കാലിയം ടു അലൂമിനിയം. ആ അല്ലേ? ഏത് ഉനക്ക് എങ്ങനെ സ്റ്റെബിലിറ്റി എല്ലാം കിടച്ചത്? ഡ്യൂ ടു ദ ഹൈലി കോൺഫിഡൻസ്, ഡ്യൂ ടു ദ സ്റ്റെബിലിറ്റി ഓഫ് ദി എൻഡ് ഓഫ് ഏത് സ്റ്റെബിലിറ്റി? എന്നാ സ്റ്റെബിലിറ്റി? പുവർ ഷീൽഡിങ്. എല്ലാം പഠിച്ചവനാണ് അല്ലേ? കെമിക്കൽ പ്രോപ്പർട്ടീസ് കൂടി വേണ്ട. കെമിക്കൽ പ്രോപ്പർട്ടീസ് okay. First one is oxidation state. Okay, what are the common oxidation states of boron family? General oxidation state are +3 and +1. Point about general oxidation state are +3 and +1. Stability of +3 down the group decreases, and for +1 down the group increase due to inert pair effect. Stability of +3 down the group decrease, and for +1 down the group increase due to inert pair effect. Stability of +3 down the group decrease, and for +1 down the group increase due to inert pair effect. Okay, it is BCl3, AlCl3, GaCl3, which is more stable. Next one is TlCl, InCl, GaCl, which is more stable. TS, which is the oxidation state is +1. Here it is +3. Okay. So here boron and aluminium. Boron and aluminium shows what only? +3 only. Okay. Gallium, indium and thallium shows what? +3 and +1. Okay. Boron and aluminium shows +3 only. So they have a very low inert pair effect. So they do not have the tendency to show what? +1 oxidation state. So boron and aluminium shows +3 only. Gallium, indium and thallium shows +3 and +1. Okay, so here we have GaX3 and GaX, InX3 and InX, TlX3 and TlX. So which have a higher stability here? GaX3. Which have a higher stability here? InX3. Which have a higher stability here? TlX. So basically in +1 oxidation state which have stability, thallium is the only one we have a stability in which oxidation state? +1 oxidation state. Others are stable in what oxidation state? +3 oxidation state. Okay. X means halogen, chlorine, fluorine, anyone. Again, stability. Okay, so here we have a M, an atom. Okay, by removal of 3 electrons it becomes what ion? M3 plus ion. Okay, so what is the energy required for the removal of first electron here? First ionization energy. For the second is second ionization energy. For the third is third ionization energy. So we know boron have high first, second, third ionization energy. Okay, which have a higher ionization energy in boron family? Down the group decrease. So which have a higher? Boron. So it have a high ionization energy means indirectly it have a high first, second, third ionization energy. Due to it has what? Smaller size. So what about the tendency to donate electron? Low or high? Low or high? Low. So low tendency to donate electron. Okay, so boron do not give what? B3 plus ion. Boron do not give what? B3 plus ion due to high first, second, third ionization energy, smaller in size and low tendency to donate electron. Okay, so if it becomes M3 plus ion, it will combines with what? An anion. Okay, so what is the compound formed will be? Ionic compound. Which the compound will be? Ionic compound. So what will the bond formed will be? Ionic bond. So boron do not give what? Ionic compound. Boron cannot forms what? Ionic bond. So boron can only forms what? Covalent bond. Okay, so boron can the or boron forms the ionic compound, all due to high first, second, third ionization energy and smaller in size and low tendency to donate electron. So what is the question will be? Boron give B3 but neum can why? Okay, boron high first, second, smaller in size. Boron do not forms ionic bond but aluminum can why? Okay, boron only forms covalent bond but aluminum can forms both covalent bond, ionic bond. Why? All have the same answer. Okay, point. Boron do not give B3 plus ion. B3 plus ion, or it do not forms ionic bond. It do not forms ionic bond, or it only gives covalent bond. It only gives covalent bond due to a high first, second, third ionization energy, smaller in size, low tendency to donate electron. Low tendency to donate electron. Okay, oxidation state. Okay, so what are the common oxidation states of boron family? +3 and +1. Stability of +3 down the group decreases and for +1 down the group increases due to inert pair effect. Okay, boron and aluminum only shows what? +3. Gallium, indium, thallium shows both +3 and +1. Which is stable in +1? Thallium. Others are stable in +3. Okay, next one, reaction with oxygen. Reaction with oxygen. So chemical property, oxidation state and reaction with oxygen. Okay, so if an element is reacting with oxygen gives corresponding water oxide. So what is the charge of oxygen is -2. What is the charge of boron family is +3. So what is the compound formed will be M2O3. So that is 3,2,4M. So that is what are the compounds? B2O3, Al2O3, Ga2O3, In2O3 at high temperature, and it also give water Tl2O3. So thallium is not stable in which oxidation state? +3 oxidation state. So it has to comes into what oxidation state? +1 oxidation state. So it becomes what? Tl2. So Tl2O3 will forms at what? High temperature. So the electrons are get excited and they shows a +3 oxidation state. But after forming Tl2O3, it readily decomposes to give what? Tl2O and plus O2 due to it is +3 oxidation state and it is in +1 oxidation state. So undergoes reduction or oxidation? Reduction. So Tl2O3 is a reducing agent or an oxidizing agent? It is oxidizing agent. So thallium +3 compounds are act as a good oxidizing agent, and here the gallium +1 compounds will be act as a good reducing agent. So it is stable in +3. So +1 to +3 undergoes oxidation and act as a okay good. Decomposes. +3 to +1 undergoes in the reduction. So here Tl2O3 is a oxidizing agent. So therefore oxidizing power follows what? Tl2O3 greater than, In2O3 greater than, Ja2O3 greater than, Al2O3 greater than, B2O3. Tl2O3 is a oxidizing agent. Due to it undergoes a reduction. So which have a higher oxidizing power is a Tl2O3. So in case of oxides of boron family, the oxidizing power down the group is increases. With higher oxidizing power Tl2O3. Okay. So there. Okay la. Generally metal oxides acidic or basic? Metal oxides basic alla sodium hydroxide, potassium hydroxide അല്ലെങ്കിൽ oxide, corresponding oxides and hydroxides are alkaline in nature. That's the reason why they are called it as alkali metals. Appa metal oxides are generally in the basic, non-metal oxides are generally acidic. So which is non-metal oxide here? Boron. So down the group of metallic nature is increase. So what is the acidic nature of oxides? Down the group decreases. Generally acidic nature of oxides down the group decreases. Okay, in case of S block elements, we are discussing about which nature? Basic nature of oxides. In case of P block elements, we are discussing about what? Acidic nature of oxides. So their basic nature down the group is increases. So that means acidic nature is decreases. Okay, so here B2O3 is acidic. B2O3 is acidic. Al2O3 and Ga2O3 are amphoteric. They are amphoteric. What is the diagonal relationship between beryllium and aluminum? Both oxides and hydroxides are amphoteric. So oxide of aluminum and hydroxide of aluminum are amphoteric. Next one is Ga2O3 and In2O3 and Tl2O3 are basic. So here the bases and acids we are using all are corresponding hydroxides. All are hydroxides. They are representing like what? MOH. If it is acidic, they are representing like what? HMO, like our H2SO4. H2SO4, it is a hydroxide of what? Sulfur. If it is acidic nature, they are representing like what? HMO. If it is basic, representing like what? MOH. So what happens? B2O3 is reacting with water. B2O3 reacting with water gives water BOH thrice. ALOH thrice, J2OH thrice, In2OH thrice, and Tl2OH thrice. Okay, so here M2O3 on hydrolysis, they gives corresponding what? To MOH thrice. So here BOH thrice, that is BOH thrice, ALOH thrice, GaOH thrice. So which is acidic nature here? BOH is acidic. That means B2O3 is acidic. Oxide and corresponding hydroxide have a same nature, acidic nature. So BOH thrice, it is equal to what? H3BO3. So what is H3BO3? Simply BOH thrice, hydroxide of boron. Okay, H3BO3, orthoboric acid.